All right, so I did one of the problems from the in-class worksheets from the first week of sound physics, and this is question number 5. The question states, a signal of 1 times 10 to the negative 4 watts is sent out from an ultrasound probe at a surface of the patient's body. The signal will reflect off of an object with an area of 1 centimeter in diameter and 10 centimeters within the body. So what really helped me approach the problem was having a drawing of what was going on. And so here's our probe that's sending out the signal, and this is the distance at which it's traveling through the body, and then here's the object that the signal is reflecting off of. And we have this diameter, and we know this length. So the power that we have sent out from the probe is 1 times 10 to the negative 4 watts. The diameter of the object is 1 centimeter, which is 0.01 meters. And the distance within the body, this distance right here, is 10 centimeters, which is 0.1 meters. So the first way to approach the problem is to find the intensity at which the signal from the probe reaches the object. And we know the intensity is equal to power over area, and we have power, and we have the area, so we can just solve for intensity. But what's important in this part of the problem is to really know which area you're going off of. And so this probe is actually sending out signals in a spherical direction, in every direction, not just in this one. And so only a fraction of the intensity is going to actually hit this object. And so to account for that, we're going to use the radius of the probe, which is 0.10 meters. So if we plug in this as our power, which is given, and our area, which was given using the radius of the probe, find that the intensity is 7.96 times 10 to the negative 4. Cool. So now we know the intensity that reaches our object in the body. Now we want to find the power of the signal once it's reflected back to the probe, and that's what's actually getting read. So we found our intensity in the previous part. So that's 7.96 times 10 to the negative 4. And we know the diameter of our object is 0.01 meters. And then from there we can find the radius just by dividing it by 2. So we know that our radius of our object is 0.005. And this object is circular. So we know that power is equal to intensity times area. We found the intensity just right up here. And then we're going to multiply that by the area of a circle, which is pi r squared. So pi, and then our r value of 0.005 squared. And that gives us a power of 6.25 times 10 to the negative 8 watts that's actually being reflected from our object and back to our probe. And then for part B, just states, what is the intensity of the reflected signal when it reaches the ultrasound probe again? So now we have, from the previous problem, the power at which the signal is, like the signal has going back to the probe, but now we want to find the intensity of the signal that actually reaches the probe. So we're going to still approach it in the same way. We know the intensity is equal to power over area, and then the power that we found in the previous problem is the power that's going from the object to the probe of 6.25 times 10 to the negative 8. And then again, our area is that of the probe. So it's a spherical area, and that's given by 4 pi r squared. And we could just plug in those values like we did before, and we'll find that the intensity that reaches the probe after being reflected is 4 times 10 to the negative 7 watts per meter squared.